Hello everyone and welcome to Geometry Lesson 2-3, Complementary and Supplementary Angles. Before we get started, let's review a couple special angle measures. Do you remember what kind of angle measures 90 degrees? Hopefully you know that's a right angle and that it looks like the corner of a piece of paper. How about 180 degrees? That's a straight angle and it looks like a line. Those two angle measures are really important to today's lesson, so it's important that you know how to recognize them. So that's enough review. Let's get on to some new stuff. We'll start with complementary angles. Complementary angles are just two angles whose sum is 90 degrees. You can also think of this as two angles that could be put together to make a right angle or a corner. Supplementary angles are two angles whose sum is 180 degrees. This is really just two angles that come together to make a straight line. Another key term today is adjacent angles. These are angles that have a common vertex and a common side, but have no common interior points. Let's take that definition apart a little bit. Adjacent angles have to share a vertex. They also need to share one of their sides, a ray, but they can't have any other points in common. So hold up 3 fingers. If you look closely, you'll see that you've made 2 small angles. The finger in the middle is part of both of those angles, but they have no other parts in common. These are adjacent angles. In these diagrams, our first angles have no parts in common, so we could say that they're non-adjacent. The second pair of angles is made by a ray intersecting a line. The ray is shared by both angles, but they have no other points in common. These are adjacent angles. My first pair of angles could be put together to make a right angle, or that corner shape. Those would be complementary angles. In the second diagram, I have 2 angles that come together to make a straight line. Those would be supplementary angles. So far, our logic has been limited to laws, properties, and postulates. But today, you get to learn your first theorem. A theorem is a true statement that follows from other true statements. Postulates, remember, were statements that were accepted as being true and needed no proof or justification. A theorem is a conclusion based on the combination of other true statements. We can justify theorems by using a set of given information and facts. This is deductive reasoning at its finest. Let's look at our first theorem. The congruent complements theorem tells us that if 2 angles are complementary to the same angles, then they're congruent. The hypothesis of this statement is that we have 2 angles complementary to the same angle. Let's say angles 1 and 2 are complementary, so the measure of angle 1 plus the measure of angle 2 equals 90 degrees. We'll also say that angles 2 and 3 are complementary, so the measure of angle 3 plus the measure of angle 2 has to equal 90 degrees. Our conclusion is that since angles 1 and 3 are both complementary to angle 2, they must be congruent to each other. Look at this! 2 theorems in one day, lucky you! The congruent supplements theorem is really similar to the congruent complements theorem. Maybe you already have a guess as to what this one says. In this theorem, if 2 angles are supplementary to the same angle, then they're congruent to each other. Our hypothesis tells us that we need to start with 2 angles that are supplementary to the same angle. In our diagram below, I can see that angles 1 and 2 form a straight line. Likewise, angles 2 and 3 form a straight line. Remember, a straight line is 180 degrees, so I know these angles must be supplementary. Since angles 1 and 3 are both supplementary to angle 2, I can conclude that they're congruent to each other. Alright, enough chit-chat. Let's put these theorems and definitions to work. In our first example, we're told that angle 1 is complementary to angle 2. Complementary, remember, means a sum of 90 degrees. So I could just do 90 minus 57 and get 33 that way, but that's boring and you guys are feeling ambitious, right? So why don't we do an algebraic representation of this instead? Algebraically, this means that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. If the measure of angle 2 is 57 degrees, I can subtract that from 90 to get the measure of angle 1. In my equation, I'll substitute 57 for the measure of angle 2, and then subtract 57 from each side. We end up with measure of angle 1 equaling 33 degrees. If the algebraic representation of that is confusing, go ahead and just use simple subtraction instead. I just want you to see that algebra set up for later on, because we'll be using expressions for problems like these instead of actual numbers. So in our next problem, we're told that angles 1 and 2 are supplementary. Angle 2 still measures 57 degrees. Supplementary, remember, means it's got a sum of 180 degrees, and then taking 180 minus 57, leaves me 123 degrees for angle 1. Algebraically, this would be the measure of angle 1 plus the measure of angle 2 equal to 180, substituting in that 57 for the measure of angle 2, then subtracting 57 degrees from each side, and then we're left with the measure of angle 1 equal to 123 degrees. Now here's one of those expression problems I was talking about. In this problem, we don't know the actual measure of either of these angles, but we know that they're both supplementary. Thinking back to our algebraic representation, if I add the measures of these two angles together, it equals 180. So let's put that down on paper. Our first angle, 4x plus 94, added to our second angle, 9x minus 5, has to equal 180 degrees. Since I'm just adding, I can drop the parentheses. Then I'll combine like terms 4x and 9x, and 94 and negative 5. Now my equation is 13x plus 89 equals 180. Subtracting 89 from both sides leaves me with 13x equals 81. And then dividing by 13 gives me my answer of x equals 7. Now here's another thing you have to be careful about in geometry. Make sure you always go back and check the original problem. So in this problem, I'm actually asked to find the measures of angles DEG and GEF. So just finding that x equals 7 isn't enough in this problem. I have to go a little bit further. So to find the measure of angle DEG, we're going to take that 7 that we got for x and substitute it in for the x and the 4x plus 94. So I'll have 4 times 7 plus 94. 4 times 7 is 28, so 28 plus 94 gives me 122. Now we'll find the measure of the other angle, angle GEF. Doing the same thing, we'll put 7 in for the x, so we'll have 9 times 7 minus 5. 9 times 7 is 63, and 63 minus 5 gives me 58. I love being able to check my work, and geometry gives us a lot of different ways to do that. So here I know that these two angles need to add up to 180 degrees, so you can check just by adding 122 and 58, and we did get 180, so we know we got this problem right. In our next example, I'm looking for the measure of angle 7. In this problem, we can save ourselves a lot of work by remembering those theorems from earlier in the lesson. I know that angles 5 and 6 are both supplementary, and I know that angles 6 and 7 are supplementary. So do you see anything special about that? Hopefully you've noticed that angles 5 and 7 are both supplementary to angle 6. The congruent supplements theorem tells me that since they're supplementary to the same angle, angle 6, angles 5 and 7 have to be congruent. Then the measure of angle 7 is the same as the measure of angle 5, which is 137 degrees. Have you ever stopped to think about all the math that's around us? How about at the beach? In a lounge chair, you know, the kind with the positional backrest? Nice, right? What do you think is true about the angles on either side of the backrest? They're supplementary angles, and adjacent too, since they use the backrest as a common side. Supplementary is 180 degrees, so in this problem, the measure of angle 1 plus the measure of angle 2 is 180. I know that the measure of angle 1 is 113, so the measure of angle 2 is 180 minus 113, or just 67 degrees. How's that for fun in the sun? It's better than a beach ball. For our last problem of the lesson, we're given two complementary angles, which means they have a sum of 90 degrees. One angle measures 78 degrees, so the other must be 90 minus 78, or 12. That's all for this lesson. Remember, you can review any part of this video if there was something in the lesson that you didn't understand. Thanks for joining me, and happy hypothesizing.